say there's a line of charge that has some length, and it has a charge per unit length of lambda, and we want to find the electric field at some point in space around that line of charge. So we need to apply these, and these are talking about x, y. So we need to put the coordinate system in this problem. Let me make this an x-axis and make perpendicular to that, passing through this point, the y-axis. And we want to find P, electric field at this point. I take a small piece here, so small that you can consider it like a point charge. And this one creates an electric field along this line, which is in this direction. This piece is at distance x along the x-axis, and this one is y, which is fixed. And this piece has a length dx, and it has a charge dq. We know that this creates dE along this direction. Q is lambda times dx. So dE, if you replace this here, it becomes k lambda dx over r squared, which is x squared plus y squared. So far, this is dE magnitude. Ey is integral of dEy, integral of dE magnitude times cosine theta. And now I need to write cosine theta also in terms of x and y. So Ey will be integral of k lambda dx over x squared plus y squared, and cosine theta is y over square root of x squared plus y squared. Ey will be k lambda y integral from x1 to x2 dx 3/2. And now we need to integrate this. Hoping that you've had techniques of integration in calculus 2. What would you do for something like this? So we see that trig substitution would work here, but what kind of trig substitution do you choose? Because this is, x is the variable, y is constant, right? So because it's x squared plus a constant squared, we need to look for a trig identity that is something squared plus a constant is equal to something squared. Right? What trig identity is that?
Tan, Anderson.
Yeah, tan squared
Tan squared
plus 1 is equal to secant squared, right? So because we have tan squared plus 1 is secant squared, we take x equal to y times tan theta. X equal to y tan theta, so that x squared becomes y squared tan squared, and plus y squared can be factored when we get tan squared plus 1 becomes secant squared, right? This is why you take this, and now we need to substitute everything. So what is x squared plus y squared? Becomes y squared tan squared theta plus y squared, which becomes y squared times secant squared theta. This way we get rid of the square root, right? Because we get something squared. And then what is dx in this case? We need to differentiate.
Y secant squared.
Sorry?
Y secant.
Y secant squared. Now plug in everything back into the equation. You see it becomes very simple. So if you plug all of this in, you get y secant squared, let me write k lambda y, integral from x1 to x2, y secant squared theta, b theta. I need to put b theta here as well, so this is differential. Y secant squared theta d theta, and denominator will be this to the power 3 half, right? Then you take power 3 half, 1 half cancels with the square, it becomes y cubed, right? Secant cube. Right? And then you see secant squared cancels out. One of the y's, two of the y's cancel out. So ey becomes k lambda over y, if you take all the y's out. And when secant squared cancels, what is 1 over secant? What is 1 over secant theta?
Cosine.
Cosine theta. It becomes integral of d theta over secant, which is cosine theta, d theta. See how simple that is. So you can actually integrate this and substitute back theta in terms of x and y. But I'm not going to do that because that doesn't give you a very nice simple expression. But look at what is theta when we define this x. What is theta in our situation? Tan of theta is x over y. So tan of this theta is x over y, isn't it? So that theta is actually this theta. So we can say Ey is equal to k lambda over y. Then this will be, what is the integral of cosine? Will be sine theta, integrate from x1 to x2. But don't convert it to x1 and x2. We say it will be theta between this value and this value. Let's call this angle theta 1. Let me get rid of that for a moment. Call this theta 1. Call this, the other side, theta 2. And that will be Ey equal to k lambda over y sine theta 2 minus sine theta 1, where theta 1 and theta 2 are the angle from the vertical of the two extreme sides of the line. Means that if you have this now, let me make this a little bit simpler with all of that, take coordinate system away. If you make perpendicular, you make, and this is the extent of the line. From here to here, we call it theta 2, and this angle is theta 1. So you say the y component of the electric field is k lambda over y times sine of this angle minus sine of this angle, theta 1. And the angle, theta 1 and theta 2, are from theta 1 and theta 2 are from vertical, from perpendicular direction, I would say, from perpendicular to the line counterclockwise. Means from that point P, you consider this perpendicular, and from there counterclockwise positive, clockwise negative. And so theta 2 is positive, theta 1 is negative here. If the line starts from here, theta 1 will be 0. If the line starts from here, both of theta 1 and theta 2 are positive. if line starts here, theta 1 is positive, theta 2 is negative. If the line starts and ends before this vertical point, both theta 1 and theta 2 are negative. Alright? So this is the result. I want to keep it like that, and then because it is a simple result, you can see what's going on. And in particular, let's explore a special case of this. What if the line is infinite? What is theta 1 and theta 2? If the line is infinite, what happens to theta 2? Yes?
90.
90 degrees. What about theta 1?
Negative.
Negative 90. So, for infinite line of charge, we have theta 2 equal to 90 degrees and theta 1 equal to negative 90 degrees. So what happens to this? What is sine of 90? Sine of 90? 1. Sine of negative 90? Negative 1. 1 minus negative 1, you get a factor of 2. And with Ey becomes 2k lambda over 1. Which is an expression that you will find in the book. But this is more general. For half of the line, half infinite line, starting from here, you want to find the electric field right at above the end of the line. You have only theta 2 equal to 90 degrees, theta 1 0, so you get kq over 1. Now, I would like to do the x component. Dx is integral of dx. Again, is integral of dE times sine of this theta, right? Yeah, sine theta with negative sign because it's in the negative side. Negative dE sine theta. Stay here and forget about theta 1 and theta 2. This was our theta, right? Theta is here, theta is here. If you want the x component of that, will be sine theta because it's opposite, but it's in negative direction, so it will be negative dE sine theta. And then dE is again this is negative integral k lambda dx over x squared plus y squared. But what is sine theta in this case? Sine theta will be opposite over hypotenuse, right? So it will be x over square root of x squared plus y squared. And therefore, the whole thing, the Ex, will be negative k lambda integral x dx over x squared plus y squared to the 3/2. How can we solve this one?
Can you substitute for this one?
U substitution works here because we have x in the numerator, right? So we can take x squared plus y squared as u, and then we take differential of that, 2x dx becomes du, then this x dx that we have is 1/2 du, and the denominator is just u to the power 3/2. So we can write this as k lambda over 2. I bring the 1/2 out. Integral of u to the negative 3/2, because it was in the denominator, we bring it up, du. Yes,
Is the negative still there?
negative is still there. Thank you. And now, what is the integral of this? Negative k lambda over 2. And this is u to the power negative 1/2 divided by negative 1/2, right? So, or it is negative 2 u to the negative 1/2, and evaluated between x1 to x2. And this negative 2 and negative 1/2 cancels out. So Ex will be k lambda u. U is that to the power negative 1/2, so it's 1 over square root of x squared plus y squared, evaluated between x1 and x2. Again, okay, you can put x1 and x2, you get this minus that, but I want to do a little trick here. I must multiply by y, divide by y. Let's say, let me do that here. So Ex will be k lambda over y, then y over square root of x squared plus y squared from x1 to x2. You see what I'm doing? Can you guess what I'm doing with this trick? What is y over square root of x squared plus y squared?
Cosine theta?
Sorry?
Cosine theta?
Cosine theta. Say y over r. So it will be this y over r when x is x1, and y over r when x is equal to x2. So it will be Ex will be k lambda over y cosine theta 2 minus cosine theta 1. Again, and for y component is by sine, x component is with cosine, and they are the same shape. And what happens if you have infinite line of charge? For infinite line of charge, what is theta 2? What is theta 1? Theta 2 is 90. Theta 1, negative 90, right? Theta 1 is negative 90. Theta 2 is 90. And then, what is cosine of 90? 0. What is cosine of negative 90? 0. So it becomes, Ex becomes 0. That means that for infinite line of charge, your electric field is only perpendicular to the line. It doesn't have horizontal or parallel component. Does that make sense? So for infinite line of charge, you have only y component. This is what I mean by integrating. You just set up the integral, write everything in terms of a coordinate system parameter, and then integrate over the charge distribution. Any questions? Now you can apply this to any situation. For example, if this is symmetrical, means that you have a line of charge, but you are right in the, so for a limited line of charge, when you are at perpendicular bisector, and if this side is the same as that side, then you have this and that, we say theta 1 is equal to theta 2, we call it just theta naught. This is theta naught, this is theta naught. So Ex is 0. Theta 2 is theta naught, theta 1 is negative theta naught. So it becomes theta naught, and sine of negative theta naught becomes negative sine theta naught. If this negative becomes positive, it becomes 2 sine theta naught. So it becomes 2k lambda over y sine theta naught. Or if you want to write sine theta naught in terms of the length and this distance, for example, if it is the length is L and the distance here is y, then sine theta naught will be L over 2 divided by 2k lambda over y, and L over 2 divided by square root of y squared plus L over 2 squared. You can write it this way as well, but it's not very useful. It can be useful, but this is easier to look at. If you have a semi-infinite line of charge, it goes to infinity, and you are at this point at distance y from this at distance y from the end of the line. And then in this case, theta 1 is what? The angle to the beginning from vertical, from the perpendicular is 0, right? And theta 2 is 90 degrees. And then Ex will be cosine of theta 2, which is 0, minus cosine of theta 1, which is 1, becomes negative k. Ex will be negative k lambda over y, and the Ey will be sine theta 2 is 1, sine theta 1 is 0, so you get k lambda over y. And you see these have the same magnitude, means that the angle of the electric field is at 45 degrees. And it has both components like that.